Hello, everyone. People are still joining in. If you can hasten them, if you can tell them to hurry up, that would be really appreciated. I'm going to start in 1 minute so that we can get going. We have a lot of work to cover today. Okay, so let's get started. And I'm going to share my screen and then people will find us where they find us. So we've been talking about object-oriented programming, and we've talked about object-oriented programming from a TOC perspective, where TOC stands for types, operations, and constructs. And if you recall, right at the beginning, we mentioned these three components of any programming language. So every programming language has got types, which are for representation, and operations, which are for action or for carrying out tasks with the types. And every type will have its type of operations, its set of operations associated with that. And you can see this if you go to the Python documentation and you look through any kind of type, and you'll see the kind of operations that are available, whether they are strings or integers or container types like lists and dictionaries or tuples. They have their own operations that you can apply. And the constructs are the language features, linguistic features, which allow you to do very specific things like branching and looping. And in Python, you have special ones for providing contexts, which you can exploit with object-oriented programming. You can define functions and you can define classes, and classes are a gateway through which you can create your own types. So we've gone through a number of examples of very simple types. So if I just take you back to our beginning with a rectangle, we started off with a very simple rectangle, and we started off by defining that a rectangle has a width and a height. And we are taking advantage of the def construct, which is a function definition construct, to then come up with, here we have an initializer that defines how, let me just modify how my screen sharing is. Let's just 1 second. I want to have a layout like that, and I want to be at the bottom of the screen. There we go. Okay. So let me just see what you see. Oh, very good. Yes, so we are using the function construct within a class construct, which then allows us to initialize our objects. When they are created, they come out of the factory very empty, so we can define how they will look like as we build them. And then we wrote our own operations, which are other methods within it. So for example, we can calculate the area, and the area takes advantage of some of the attributes. We reference the attributes using the self keyword. And from that, we can then do other things. We can calculate the size, the perimeter, the bounding box, diagonal. We even looked at some details about the bounding box. So that was all that we did in the first class on introducing Python object-oriented programming. The next thing that we looked at was inheritance. And we started off with an example from a square, where the square borrows from the rectangle, and we define a very simple interface to how to define it. So we just give it one width attribute, and we pass the rest using the super keyword. We return this now back to the parent class, which is the rectangle class, where we now repeat the width attribute or the argument. We also looked at some special syntax using the star args and double star quags. And these are a means by which we can just pass everything up to the parent class without caring whether the parent class is going to introduce new arguments to its methods. So, and then we now went to the Canvas class. And in the Canvas class, we now became more practical. We are borrowing from the turtle screen class. And that class then allows us to specify a number of attributes. So we have a canvas, which is provided by the turtle library. And we have the screen size, which we can set. So this is the fix that I needed to make, though I don't see it working as it should. We also defined the pen, and we'll be looking a lot more at this today. So the raw pen or raw turtles, just synonyms, are now the things that are actually used to draw. And when we ran this, we saw some very interesting behavior. Let's just run this and then I'll show you on the screen. So we actually see that it is drawing. I don't know why it does that. So it actually does draw, and it draws an axis, which is centered on the center of the page. Okay, so that's it for the two ideas. One is using the class construct. Then we looked at inheritance, and we are bridging that with the use of the turtle library. I'm going to pause here. Are there any questions? Anything that in the course of trying to solve these problems, the exercises that I've given you, anything that's cropped up that is confusing or is a stumbling block? I'm going to pause here for any questions. Okay, no questions. Okie dokie. So today we are shifting gears. And now that we've looked at the foundational ideas, now we want to go on to polymorphism. Now with polymorphism, things become a bit abstract. So I need you to pay a special attention today. So when we're dealing with polymorphism, the idea behind polymorphism is that you provide interfaces that are within their definition. They can do what they need to do, however they need to do it, without changing how they look like from the surface. And we're going to see how that actually works with examples. Poly means many, and morph means shapes or forms. So many forms, but the same interface. We want to try and simplify how we connect the canvas with shapes. We can have different types of shapes. We've seen rectangles, we've seen circles, we've seen squares. Each of them have their own peculiarities when it comes to being drawn. But drawing a shape for the user is independent of the shape. When a user wants to draw a shape, they don't have to care what kind of shape it is. And that's really where the polymorphism will apply. So let's just recall types, operations, constructs, okay? And we have created our type, circle, rectangle, canvas. Now we want to provide operations using methods. We've done a bit of that. We've calculated area and so forth. But now we want to do the drawing. And this is really where we need to pay attention. So we have the following skeleton. We have the canvas class. The canvas class inherits from the turtle screen class. It's got other attributes and methods, but now we want it to draw a circle. So we are going to draw a circle. If you recall from one of the earlier exercises, when we drew a circle, let's just look at that. I'm going to go back to that. So we did have drawing with turtle, and we had this example here. And in this example, we had drawing a circle involved. Let's run this actually and see what we get. So it's drawing it on my screen. I don't know what you've seen. I don't know why it then shuts down. That really is annoying. I don't like that. I don't know why it closes it. I find that really annoying. Turtle.done. Anyway, but we've seen how it does that. So we have this useless timer, which I'm going to remove. So we get the pen, which is turtle.turtle or raw turtle or raw pen. And then we move the pen to a certain location. And then we draw circle using the pen dot circle with the radius. Now we could actually modify this and add a variable, an argument that specifies the radius. So for example, if I said this is radius, then we'll have to pass in radius. We could have a default value of, let's say, 60 as what we had before. So now for us to draw, let's say I want to draw one with 180 and I run this, then now I'm drawing a big, oh, oh. So there I'm drawing a big circle on the screen. I need to figure out why it keeps shutting down into a tiny screen. I have no idea why it does that. Okay, so now that we did that before, pen.circle was for the radius. So I'm going to give you an exercise. If you have already pulled the code, I will now go back here into our OOP circle. Okay, and now within your Canvas class, what I'm going to ask you to do, we'll keep that hidden there for now. I want you to implement a draw circle. Draw circle class, which takes a circle. And I want you to implement this. So I'll just push this skeleton for drawing a circle. So if you can pull the code, to pull the code, if you're using the repository, let's just see, I have a typo somewhere, draw circle, that's a typo. That's just a circle again. Circle. Okay, it's just annoying. Typo, fixed typo. Okay, so I've pushed these up. I can actually show you how to use the terminal if you want to pull. How many of you have not pulled the repository before? By a show of hands, I'm saying, I'll just put it in the chat. I have not pulled the repo yet. So could you give a thumbs up to that? Just to give me an indication, and I'm going to show you how to do it if you've not done it before. Okay, so everyone has it. Okay then. Okay, so just implement that draw circle. I'll give you 5 minutes for that. Okay then. Do you have a laptop or are you using a phone? Okay, so you're on a laptop. So this is what I would ask you to do. I'd ask you to just look at my screen. So what you'll do is you'll go to File, and then you'll say Project from Version Control. You'll select that option, Project from Version Control. Now I'm going to paste for you. So if you click Project from Version Control, it's going to open for you a dialog box, which gives you the focused item will be the URL field. So sorry if this is really small, but let me then, okay, so now the URL, so let's come here. Okay, then I see why it's doing that. I have to, so let's go back for Korir, Python for engineer. So essentially what you need to do is, let me zoom in here. On the repository, there is a green button right here in the center, which says code. You click on that and you get the URL from there. So you click copy URL to clipboard, and then you pop it in here. And then you will click clone. I don't want to do it because I already have the repository. So you'll click clone, and it's going to pull all the code, and then it'll ask you, should I open this in a new window or in the current window? And you should tell it open it in a new window. So I'm waiting to see you do that, and I want to see a check mark or a thumbs up once you are done with that. If you want me to repeat, let me know and I'll repeat. Okay then. Um, I'm going to ask you, admin, could you please share your screen and I'll walk you through it on your screen. Okay, thank you for confirming. XS Max. Well, I'm waiting for admin. Admin asked me to repeat. Okay, thank you. You're sharing your screen. Okay, then. So, okay, very good. So the first thing you'll do is you will click on this hamburger menu here. And then you're going to click on File. And then you'll click on Project from Version Control. Now you're going to paste the URL from GitHub. So you have to go back to GitHub, and actually, let me paste it for you in the chat. I'll just paste whatever you need to. So just copy and paste the text that I've just put into the chat. So just copy that text, paste it into that URL. And then click on clone. You don't have to. Try and keep the default options. Wherever you see, okay, then it's going to ask you, it'll throw up a new dialog box. Yes, so new window. Don't say this window. New window. Trust and open project. Yeah, trust. So it'll open for you a new window with PyCharm and this project. So you'll probably need to do a fresh share. At the moment, I only see the previous one you are sharing. But let me know if it works. You should have the code up to date. Okay, let's see your sharing again. Okay, drawing turtles. Now, you will need an interpreter. So what you should click there is configure a Python interpreter, add a new interpreter, add a local interpreter, and wait, just 1 second. Wait 1 second. Let's just make sure we get this right. So your environment, it's a generator new. It's going to be, um, okay, yeah, that's fine. So your type will be virtual env. This is good. You're using Python 3.13 at the latest. It will put it inside the folder, which is good. Ignore these and just click OK. So you will see a new folder here called .venv. There we go. Okay, so now if you go to the OOP circle module, there we go. And now if you scroll down to canvas, yes, scroll down a little bit more. So there is your method. So you need to just now add the code. If you want to know what the code will look like, look at the drawing with turtles module. And that shows you how to draw a circle. So now you know how to draw a circle. I've given you the stub for the canvas method called draw a circle. So now I'm giving you a couple of minutes. Try and write the code to draw a circle based on the attributes of a circle that are provided on the circle class. So if you scroll, okay, I was going to show you how to fix that error, but it's okay, carry on. So I'll extend the time. So I'll give you, okay, you're sharing your screen again. So you have an error there. So what I'll ask you, the first thing to do is, um, can you, if you bring your mouse on this line here, you should see a size handler, which would be two arrows. Just bring your mouse pointer on the line between this block and this block, and it will change into an arrow like this. Just hover the mouse, just bring it down, bring the mouse down, 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 down. Oh, there we go. You see that's a size handler. Now drag it upwards. There, very good. So here is it's telling you that we have an indentation error on line 98. If you click on this link, click on that blue. Okay, then it takes you immediately there. Now you can use a size handler to push this down. So line 98, we have an indentation error. Why? Aha, it's because we have nothing here. It's expecting some code here. So that's where you add it. That's why it won't run. So kazi kwako, kazi kwenu. Thank you for sharing, admin. Really, really appreciate you sharing. That has been very, very instructive, I hope, for everyone. So 5 minutes, everyone. I'll give you 5 minutes to finish up this because so at 31 we shall proceed. If you have any questions, just post them in the chat. Okay, is there anyone who would like to show us what they've done? And then we can give it a go and see if it runs on your computer. Anyone kind enough to share with us their screen? Okay, so I'll just do the implementation, then we'll move forward. So here we have draw circle. The circle will have a radius, so we can actually just reference drawing with turtles. So if I basically just copy this and I put it into my OOP circle, and then from here I can begin to reason about what I need. So the first thing is we already do have a pen, and the pen is defined here. So we don't need to say pen, we'll just refer to self.pen. But what we don't have is the radius. So we'll always refer to here self.pen. I'm going to show you a trick. In PyCharm, you can actually get it to, you can, I don't know if, let me see if I can find that, column selection mode. So if you select column selection mode, you can literally select a column of text and you can edit self.pen multiple lines at the same time. So we don't need this line. Now, once you enter column selection mode, just be aware that it will stay in column selection mode, and any selections that you make will be strange. So you'll have to switch off column selection mode to go back to normal mode. So here I can use, I think, the Alt key to select multiple points at once, and I can say self dot, again, pen. If self dot pen is down, put the pen up. Now, the circle, let's just go back to the circle. Now for the circle, remember we define both the position and the radius. And the position is a tuple. It's got two values. We just take it directly from here. So that means we will need to know what that position is. So instead of here 15, we'll say we can get the position. So we can say x and y is equals to circle.position. Now I'll explain what this is. It will be, this is called an unpacking operation. Now let me illustrate what that means. I'll come to the Python console just to illustrate what that means. So imagine that I defined position as a tuple. Now to define a tuple, I need to have at least one comma. So if I just use parentheses and I put 5 to try and make a single tuple, that is not a tuple. There has to be at least one comma. So suppose I say position is 5, 10. Okay, now that is a tuple. We can check the type of position and we see that it's a tuple. It's a class tuple. Now, what I can do is I can actually unpack it. If I say P, for example, is equals to position, I have just created another tuple. So P will still be of type tuple. Okay? But if I put as many items, as many variables as there are in the tuple, I can unpack multiple variables at once. So for example, I have X and Y. Because I have two values inside my tuple, I can unpack them. So now position, if I assign that, now X is an integer and Y is an integer. So what I've just done is I have unpacked a tuple into multiple things. Then there are different things more advanced ways you can do this. But for now, this is the important point I just want to highlight here, that here I'm doing an unpacking operation of a tuple, any sequence type, which is can be a list, a tuple. I think you can do the same with mainly those two. Okay, I think you can do the same with a set as well. I'm not sure. So now we have X and Y, and we can put X and Y here. So now we can put the values of X and Y there. So we have unpacked X and Y from the position, and we have just used them there. Now, the only other thing we need to do is to get the radius, but the radius is found on the circle. So we'll reference the circle object, which has a radius attribute or radius property. And that's it. I can remove this tuple down. I think that's just giving us trouble. And I'll clean up my code. And now I have a way to draw a circle. So let's actually put this into use. So we come back to our main method here. We've created a canvas. We had created a circle. Let's make it a bit fancy. So here, the position changed. So that's fine. That's perfectly fine. And now the thing that we will need to do is we will need to now draw the circle. So we'll say canvas dot draw circle and the circle we had defined. I'm going to pause here for any questions. Any questions of what I've done so far? Going once, going twice, going, gone. So let's run this now. So if we run this, we see it will draw. I see what it's doing now. I see what it's doing. It's when I change screens, it behaves differently. I'm just wondering, how do I force it to draw on this other screen? That's just what I'm struggling with here. Assign to all desktops. Let's try that again and see if that works. Okay, you probably saw that. Okay, that's much better. For some reason that behaved. Let's change the radius. Our radius is too small, it's 5. Let's make it 20 or make it 80. Okay. So let's run that again. I bring it here. So you can see it draws the axis and then for some reason it hasn't changed the dimensions. I don't know why. Why didn't it do that? Let's try that one more time. Okay. I think I know. Okay, sorry. It changes back to 17. So this is annoying. So it'll always draw it at 17. So let's just do it one more time. Oops. Okay. Oh, there we go. That's much better. Okay. Let me do that one more time and I bring it for you to see. So that it's drawing the axis and then it comes and draws a nice big circle. Okay, there we go. That's it. So now we can draw a circle on our canvas. Now let's just think about this. So this is what we're actually doing. Canvas draws circle and it actually draws a circle. Now repeat the same for the following methods. Draw rectangle, draw square. I'm going to leave that for you as an exercise so that we can move faster. I will set that up for you as an exercise for polymorphism. Maybe, let me just give you a chance. Just draw a rectangle. Let me give you 5 minutes to draw a rectangle. 5 minutes to draw a rectangle. So let me push this code so that you can have draw canvas, draw circle. Now, if you want to get the latest changes, you'll need to come here and then right click and choose Git and pull. Git and pull. So right click on the folder, select the Git option and look at the pull. So the pull is it's going to pull the latest changes. And you may stumble, you may encounter some problems, but I'd love to see those problems so that we can fix them. So 5 minutes, draw a rectangle, please. You can do the square later on, but draw the rectangle. 5 minutes. We'll be back at 45. Okay, let's continue. So now we can draw a circle. We should be able to do the same thing with a rectangle. So we already have the instructions on how to draw a rectangle. So I can essentially just take this and I can paste this inside a new method called draw rectangle. And it takes a rectangle and I paste that in there. Now the only thing is I don't want it to be turtle. I'll just use the pen. So I'll go to color mode, self.pen, and that should work. I'll get rid of this. Now the other thing is I need the direct dimensions of so I will do the same thing. I will say if self.pen is down, self.pen.up, and then I'll go to the position X, XY is rectangle position, and then I can go self.pen.go to XY. And then from that point, now I use the dimensions. So the forward will be the rectangle. I'll call it the length. No, the width. And then I'll have rectangle dot. But it will rotate by 90 degrees. So this is a 90-degree rotation. And then here we have now let's just still rectangle dot height. And again, this is the angle. And then we have the width again. And then lastly, we have the rectangle dot height. Now, the only thing that I haven't added here is the fill. So I'm going to say begin fill, self.pen.begin fill, and we pick the color. Now, previously I didn't pick it, but I should have said circle.stroke, which is the pen color, and circle.fill, which is the fill color. We'll see, maybe that'll fail, maybe it'll work. We'll figure that one out. So we do the same thing here, self.pen.begin. So we begin fill and we say pen color is rectangle.stroke, which we have from the rectangle, and self.pen.fill color is rectangle.fill. This is American spelling. And when we finish, we end fill and pen up. Self.end fill, pen.end fill, and self.pen up. So let's just see what we've done here. We have to make sure the pen is up so that we don't write as we go to the position. So we are going to the position. And then we begin the filling process and the pen color and the fill, and then we do all these. So now we have a rectangle here we've defined. So we had a rectangle. Where is the rectangle? I don't think we defined a rectangle. So I can define a rectangle. So drawing a rectangle. So rectangle. So rectangle is equals to rectangle. We shall set the height to be 150. So the width to be 150, and the height is 87. And then we shall, let's see how it works. So now we have a rectangle and we want to draw it on the canvas. So we'll say canvas draw rectangle rect. So I will not draw the circle here just for us to save time. And let's see how that works. So there we go, we are drawing. And then we go to a certain position and we draw the rectangle. Now, I don't know if you can see this, but the colors that we used, you may notice that it is a bit lighter here. So let's change the stroke and we set the stroke and the fill. So we'll set at the moment, the default for a rectangle. For a rectangle, we have the fill is white and the stroke is black. It's not very helpful. So we can change those colors. Let's use, we shall use a fill of blue and a stroke of orange. Let's see if that's going to help. So we draw that again. So it's drawing. And then it goes to a certain position and it draws blue. The orange is very thin, so you can't really see that. But there we go. We've drawn a blue rectangle, and this rectangle is located at a position. So it actually uses the top left coordinates as the coordinates of where the rectangle will be. So if we change that, so let's just change one last thing. We change the position and we set the position. Imagine it's somewhere in the top left quadrant. So that will be an x of minus, let's say 250, and a height which is positive of, let's say 193. So let's draw that. So there we go. So now we are drawing our rectangle, and then we go up, and then we draw a rectangle. So there, that position is roughly minus 250, 153, 193 or something. Any questions? Why do we use self.pen? Good question. Let's give a thumbs up to that question. That's great. Well, I don't know if your question is asking, where does the pen come from? So we are using self.pen because we defined the pen on the class. Here, self.pen, we put the pen inside. So now we can reference, it's the same pen that's used to draw circles and rectangles and everything else. So instead of, if you recall from this drawing with turtles, specifically the drawing circle, we had to get the pen from scratch. And then we got it from turtle to turtle. And then we used the pen inside. But now for the canvas, every canvas comes with a pen. Every canvas comes with a pen. So we set the pen, and the pen is what we will use throughout. Whenever you're drawing a circle, you refer to the same pen. Whenever you're drawing a rectangle, we refer to the same pen. Does that make sense? Okay, great. So now we've drawn a rectangle and a circle. Now, I hope if you're noticing that this is getting tedious, because if we had to draw it for every shape, we have to write a method for drawing. That is tedious. We want to get out of that problem. Is there a better way? And this is where polymorphism comes in. So here's a thought. Suppose we gave each circle, each shape, the responsibility for drawing itself. What if we made it such that circle had a draw method, but now the pen has to get its way to the circle? So that's going to be difficult. We'll always have to pass the pen from the canvas. Okay, so this is halfway through the solution. The other solution would be if we had the canvas and the circle, so they are both the way they are, and we told the canvas to draw the circle, and then within the canvas, it would pass the pen. Okay, within the canvas, and I'm going to do that practically. This is now where we begin to get some traction. Okay, so here's the idea. The idea is that we will replace these two, draw circle and draw rectangle. We will actually, I'll leave them here for now. But imagine if we had a method called define draw. It doesn't care, and it takes a shape. Okay? And we shall define what this is. So I'll just put a blank line here, pass, which is valid Python. Now let's come back to our circle. And in our circle, we'll give it a job of drawing. We say self.draw, draw. Okay, so now we have two draws. Okay, there's a draw within circle, and there's a draw, let me collapse this, within canvas. Now notice here, I just say draw shape. And then here I simply say now, I will assume that a shape has a draw method. So I will say shape dot draw. And I will give it the pen. That's all I need to do. So now, because shape will be the one to do the drawing and it needs a pen, then I need to have a pen received by this. So I need to have a pen here. Okay? I'm going to pause here for a second. I've made a shift here. So previously, the canvas was responsible for drawing all the shapes. All a shape had to do was to show up in the canvas in the appropriate method. And we said, no, that's going to be difficult because every new shape I draw, I now have to add a new method within the canvas to do that shape. That's not right. And so what I'm saying is, why don't we just have a draw operation? And the canvas's job will be to draw a shape, but the shape will also know how to draw itself. So the responsibility of drawing is now delegated to the shape. And in the canvas will then use that method. So the canvas here will say draw shape. Here I'm just using a generic shape. No particular shape in mind here. It's just a generic shape. Sorry. So here I'll say generic shape. So it would be generic shape, can be any kind of shape, okay? And when I say draw, I don't have to care what kind of shape that is. I just say shape.draw, and it will be responsible for that. But the only thing is, because the pen is defined on the canvas, the pen has to be passed on. Okay, so imagine here, let's just add an imaginary line here. Imagine if shape was circle, then we'll be saying circle dot draw, and we'll pass it to the pen, self.pen. It's self again because it is found on the object. That's how we refer to things within the class. So if we come back here now, we'll take a variable called pen. It turns out that this was passed from the canvas, but all we care is that there is a pen that we can use. And we'll just use the pen because it's been given to us. Okay? And then now, what we'll do is we'll now do the definition. So let me take this. Just don't worry for 1 second. I'm going to fix this. It's not going to be self.pen because we got the pen. So we need to now remove all this reference to self because the self is a circle. A circle doesn't have a pen. The pen is given from the canvas. So here we just need to remove all these references to self because the pen is something that is passed to it. I'm just to just make that change right now. 1 second. So now we are just referring to the pen that was given to us. Okay. And now instead of saying circle, because this is a circle, circle is self. So we'll just refer to self dot all these other things. Okay. And that's all we need to do. So if we now, so let me summarize what we've done. We've said, I'll come back to the slides. So we started off by defining shape-specific methods for drawing on the canvas. This was on the canvas. We had a draw circle, and then we had a draw rectangle, and we started getting tired because there's any number of shapes that can exist. We don't want to keep doing this. That's just tedious. And so we say, okay, then one option is we pass the pen directly to the circle, and then we tell the circle to draw itself. But we want the shape, we want the canvas to do the drawing. And so what we do is everyone has a draw method, and the canvas will be given a shape. Sorry. Yeah, so the canvas will be given a shape to draw. So this is just, here it's circle, but then in general, it's any kind of shape. And then within the canvas, it will just say, you draw yourself. Then the circle will say, oh, I don't have a pen. And the canvas will say, oh, okay, then here's a pen. And the pen will be handed over from inside. Okay, so this can be any generic shape. Let me just put this here. Can be any shape. Doesn't have to be circle. So when the circle knows how to draw itself, and the canvas doesn't know how to draw shapes, it just asks each shape, draw yourself. Just draw yourself. Okay, that's it. Now let's see how that works, and whether that's any better. So now we have a circle we have defined here already. We have a circle. Let's hide this rectangle for now. So what we want to do is we just we'll just say canvas dot draw circle. And circle will now take on, you'll say, oh, you've asked me to draw. Then I'm going to draw myself. So let's see that in action. So there we go. It's drawing the grid. And then it will go and say, hey, circle, draw yourself. And then the circle will draw itself. Okay? Now we can do the same thing with the rectangle. So it's the same thing. But now we don't even have to define it on the canvas because the canvas takes any shape. We just have to go to the rectangle. So let's go to the draw rectangle. We take all of this and we will define it within the rectangle itself. So I'm going to close this. Within rectangle, I'll now define a draw. So def draw, draw, and it takes a pen, just like with the circle. Now we'll have to again make those changes. So we are not referring to, here self is a rectangle, and the rectangle doesn't have a pen. So we now need to, we will just remove all these references to self. And we'll change every reference to rectangle. Self is a rectangle, so we can now change rectangle to self. Oops. Okay. And now we can simply say canvas. Here we'll say canvas. So we define the rectangle here, and canvas dot draw rectangle. We haven't made any change in the canvas. The canvas is exactly the same as it was. And let's run this. So now we see drawing the axis. It comes and draws the circle. And then it goes and draws the rectangle. And it's now the rectangle itself that is responsible for the drawing. I'm going to pause here. Any questions? Because that was a quite an inflection to make that transition from the canvas is drawing every shape and say, no, we don't want to do that. Let every shape have its own responsibility for being drawn. The only thing is the shapes don't have the pens. So they have to get the pen from the canvas. Everyone will define a draw method. The canvas will define a draw method. The shape will define a draw method. And then when we try and draw, we'll just ask, whenever you ask a canvas to draw a shape, the shape will just say, shape, draw yourself. But the pen is needed. So it will give it the pen from inside. So if you look at that for rectangle, let's just look at that for rectangle again. So for rectangle will now have its own way of being drawn, but it needs a pen. And that pen, it'll just do what it did before, but it's getting the pen from somewhere. Nobody knows. It doesn't care. Okay? So this now is polymorphism. There is one method called draw, but that implementation of draw depends on each shape. And each shape is given the responsibility for defining how it will realize the drawing operation. That is polymorphism. Okay? So now we have delegated the responsibility of drawing to the shape. And so we are using a generic argument here called shape. I don't care what shape you are. I don't care. All I care is that you have implemented a draw method, and I'll call that draw method. And by calling that draw method, I will ask you to draw yourself. All you need is a pen. Here's the pen. Shika kalamu. Enda ujichore. So we have relocated the draw method. Now each shape will have its own draw method, and Canvas will have a draw method, which will call the shape's draw method. So canvas, circle, rectangle, square, each of them can be drawn. Draw, circle, draw, rectangle. One method, and different behaviors. That is polymorphism. I'll pause here. So do we still pass arguments for every shape we want? Great question. Let's just show him some love. Do we still pass arguments for every shape we want? Now, I want you to be specific. Which arguments are you referring to? You can come off mic. Which argument are you referring to? There is only one argument. Okay, okay. Position and radius. Okay, that's a good question. So let's come back here. Just come back here and let's just pay attention here. Whenever we create a circle, we will specify how to define a circle. We'll say the radius, we'll say the fill, we'll say the stroke, we'll say the position. That defines a circle, and we are done with the definition of a circle. When we define a canvas, we say this is a canvas, it is this big, it has got this, it has got this, okay? And then we are done with the definition of a canvas. So now whenever we are doing drawing, we are just using the things that have been defined. So we don't modify anything about the arguments for each shape. Those come with the shape. And this is the idea of encapsulation. Encapsulation is essentially you have put a cap around a thing. You have defined it in a nice, clean way. So we don't have to keep redefining it. Once it is defined, it is a thing. And now we can use it. So we have a circle, we have defined the circle, we have a canvas, we have defined the canvas. What do we want to do? We want to interact with these two objects. Well, they do that through the drawing method. We say, canvas, can you draw a circle? But we don't have to define any other arguments for every shape. Does that make sense? Does that answer your question? So if you notice, we defined the circle, we defined the rectangle, the square, we defined the rectangle, and then we just, after we defined the canvas, we drew. We did not make any more changes once we did that. Okay, so this is a key idea. So the ability for a property or an attribute or method to have object-specific behavior, that's what polymorphism is. It is poly means many, and morphism means forms or shapes or appearances. This is a very important thing in OOP. It will take you a while to learn OOP. So it will take you a while to learn polymorphism because it's not obvious. In this example, it's quite clear. We have illustrated very clearly. But in the real world, you will stumble before you actually master it. But the key idea is you have a single interface, draw, and various behaviors. Behaviors that depend on the particular circumstances. Now, I'm going to give you a challenge. Can you create a drawable triangle? Create a drawable triangle. So here what you'll need to do is, let me just write for you on the screen. There'll be a number of things you need to do. I don't know if this is going to be the best way to do it. Let's just see. So what are the key steps? I want you to type them out in the chat. What are the key steps to create a drawable triangle? What is number one? Number two? Actually, they're just two main steps. So what would be step number one? Let's type that into the chat. Okay, now we're talking about the attributes, angle. Okay, now what I'm talking about is the actual big steps. So let me give you step number one. So thank you for that contribution, Owen. I'm going to just give you a thumbs up. Let's give him a thumbs up for trying. So we first have to create the triangle class. Oh, this is horrible. The triangle class. And that's now where, I don't know, angle will fit in, but that could be one attribute of that. Like if you were to draw a triangle, what do you need? You need 3 points. I would actually ask you to go to the documentation of Turtle and find, is there a way to draw a triangle? So this one, go and check. in the turtle library. I'll leave that for you to do. The next thing we do is once you create the turtle class, so within that, there'll be sub-steps. That step number one here is you need the attributes, of course. And if you want to calculate the area and things like that, you can also define area, perimeter, and so on. Every shape comes with new things. But then the most important is we want to have a draw method for our drawing operation. The next thing you'll need to do is you will then now instantiate a triangle. And then the third thing you'll now need to do is then you'll now draw it. So you say canvas dot draw, and you'll draw your triangle. Okay, so I'm going to give you 5 minutes to do that exercise. 5 minutes. Let me give you 10 minutes. So we'll be back at 15:21. 15:21. Any questions? Any questions? Put them in the chat, please. Any questions? So how do you define a triangle? Any ideas? How do you define a triangle? You can start by going to the drawing with turtles and create a triangle in there. Draw a triangle. Ooh, is this thing listening to me? Okay, so what would be the simplest way of drawing a triangle? You can start with a very specific triangle. Say, for example, assume the triangle has one of its vertices at the origin. So you can just draw, you can say pen dot forward 100. So for example, let's start with the simplest. We start with a right triangle, which has got dimensions of 5 for the hypotenuse and 3 and 4 for the height and the length. So we need a pen. So we need to get the pen. Oh, actually, we can even just use turtle just to get this going. So turtle dot forward, and then we say if it is, we are drawing the height. Let me just draw this on the screen so that you can see. So suppose we want to draw like, so this is the origin, the axis, and we want our triangle to be like that. So we know that this would have units of, let's say, 4, that would have units of 3, and that would have units of 5. And we multiply by 10, it's still the same thing. So if we went forward, so we started off by going forward here. So this is forward, and then we'll turn by 90 degrees, and then we'll turn by whatever angle this is. We can actually, even from here, we can just say go to, and we go back to the origin. Go to 0, 0. And it will draw because the pen is down, right? So let's just try and figure this one out. So we are going forward by 50, by 40, and then we shall turn turtle right, we shall turn turtle left, 90 degrees, and then turtle forward. Oh, it's like it's listening to me. Forward, we'll go 30. And then now we shall not turn left because we don't know what the angle is. You can calculate the angle if you want. We shall then, we'll say turtle dot go to 0, 0. Okay. So let's see if that works. I'm going to say draw triangle. Let's see if that works. If I run this, okay, it does do something. I don't know what it does. Oh, I have to tell it turtle dot done. Let's just use turtle dot done. Let's run that again. And there we go. We have a silly little triangle that we've drawn, if you can see on the screen. So let me multiply that by a factor of 10 and see if we can get a bigger triangle. So we make that 400 by 300. If we run that now, we run a nice big triangle, as you can see. So that's a simple triangle. If this triangle has got, we have at the moment it's quite simple, but if you wanted an arbitrary triangle, then you now need to think, what do I need to do? But we can start with this and then we add arbitrary complexity later on. So now that we know how to draw a simple triangle, let's use this and we'll just take that code. I'll just take that code and I'll come here and I'll create my triangle. I'm just trying to think because I have so what is this? If I create my triangle class here, class triangle, and it doesn't borrow from anything, and def init. Now this is where it gets complicated because I have to know how do I define a triangle. So this is where it gets, there's a question mark there. I don't want to think about it now because and I just pass. But we'll have a def draw. So let's just say, I'll just leave this blank for now. It'll initialize as an empty thing. And draw, I'll just put this here for now, just as a stub. And we draw with a pen. And we use the pen for all these things here. Pen dot that. Okay, and we have, I'll just remove this now. So let's see, draw. Why is it highlighting? Maybe draw may be static. Yeah, that's true, because I'm not referencing the object itself. But let's just see this in action. We'll create a triangle with that. And we'll have the canvas dot draw triangle. Okay. Now we know that this is a fake one. At the moment, we're just illustrating how it works. So let's just look at that. So here we're drawing that was our mystery method. We draw our circle, we draw our rectangle, and then we've drawn a triangle, but I can't see it. Oh, okay, that's because we are not at the origin. So what we'll do, we'll go back to the origin. So we'll have to go back to the origin. So these are the little bugs that can happen. So we'll have to say pen.up, pen.goto, and then pen.down. So let's try that again. So it draws. Now remember the stroke, I think it will take the color of the last stroke. We've drawn a rectangle, then we draw that. Oh, look at that, they drew the triangle, but it's sort of funny angle. I hope you see that. Okay, cool. Any questions so far? So I will commit these changes for you, and then you can pull them later on. So I'll just commit draw a simple triangle. You can spend a lot more time thinking how to do this completely, but that's just the starting idea. Now let's change gears here, and now let's look at text, writing text. So we have a text class, and we want to have the same thing. We want to have a draw for the text. So using the same idea, now we need to do this to our text. What do we need to do for that to happen? So for that, we'll have to come to our documentation and let's look for a way to write text. So there should be a text method if we write. So here is write, align, font, arg, object to be written to the title screen. So we do have our text. So we can try that out. Let's go back to our drawing with turtle and see if we can draw some text. So if we come back to drawing with turtle, now we want to write some text. Let me just hide these close annotations. This is just making things like difficult. So now I want to draw some text. So I'll write a function called draw text or write text. And so now I'm referencing the documentation. I have here turtle.write, the object to be written. Okay, here it's a string. Okay, align it to be left, font is Arial 8 normal. So you can actually let's copy that. Let's use that. So here we say turtle.write and we say text. And does it give us the position? No, it doesn't. But let's just see what happens. And we give it some text. So this function writes text. somewhere. We'll see where it writes the text. So let's just, so we say write text hello world. Okay. Let's see what happens with this. Nothing. So I'm probably using the wrong method. So let's look at our documentation and see if we can find align center. We need something that can write, can tell us where to write. So now I'm just searching through the documentation, pen control, write, turtle state. Clear timestamp. There should be something here in the introductory bit. There's a title, background color. So let's see. I don't know if I have it in the notes. I probably have. So write, text dot write. And I think, so there is, I don't know what it is off the top of my head. Let me just find it in the documentation. If you find it, please paste it in the chat screen. So we have, these are positions for moving and drawing for the position of the state, drawing state, visibility, special turtle methods, methods and turtle screen, animation, input, text input. This is for getting text input. Pop up a dialog box on the, okay, that's not what we want. Color mode, get canvas, window height, window width, exit, setup, title. But there should be a way to write, and we need to write with position. More drawing controls. So write. Okay. Write text, the string representation of arg at the current turtle position. Okay, so it assumes that position is provided. So we'd have to say where to write to. So we'll say something like, let me close this, it keeps opening, it's annoying. So if you say turtle dot go to, so here it is going to that position. So let's go say 2020, and then we'll say turtle dot done. Okay, so let's try that again. Aha. So there we go. We have some text written out there. Hello world. But the problem is the pen was down. So we'll say something like, we'll have to start with something like turtle pen pen up, because we don't want it to write. Then let's change some of the parameters. So we'll say, let's say the font is Arial and 20 normal. Let's see if we can change the color. Font. Okay, let's start with that and see what that looks like. Aha. So now we don't have a line which is being written, but we have the text being written out. Okay. Okay, so now let's actually put this into our class, our text class. Okay, so now we have text. If we come back to our OOP, we have text, the text that needs to be written, the position it needs to be written at, and we want this text to be written. So we'll give it a method, a special method called write. And all it'll take is the text that needs to be written. And then it'll be responsible internally for actually writing the text. So here I think we take the pen. We can take the pen, because the text is defined internally. So we have to take the pen just as before, and then we'll say pen dot up, then pen dot go to position. So this is another way of saying it. We are referencing X and we are referencing Y. And then now we can pen.write. I think pen.write should work. Let's try that. Let's see if it will work. It might fail. Pen.write. No, that won't work. It has to be turtle.write. Right. Is there turtle.text? Maybe turtle.text. Text input, title, prompt. No, that's not what we want. We want turtle.write, and we want to write the text, self.text. And at the moment, let's have it font Arial. Let's call this 40. We'll change the color. We can change the color later on. And then pen turtle.done. No, that's fine. So now we need to give the canvas a way to write. So just in the same way that we had the draw, we shall have a write. So def write will take some text and it will say text dot write, and we'll give it the pen, self.pen, and that's it. So just the same way the draw takes a shape and asks the shape to draw itself, similarly, we take some text and ask the text to write itself. All we do is give it the pen. So now we haven't defined any text here anywhere, have we? So now we can define some text. So text is equals to text, and we give it some word, hello world. And we can set the position. Position is equals to, let's do something fancy, minus 72 minus 67, okay? And then we just say canvas dot write text. That's what we'll ask it to do. So it's the same idea. We ask the text to write itself, and we just give it the pen, okay? And we have a write method on the canvas. So now canvas can write text. So let's see how this works. So first it draws all the other shapes. It draws the coordinates, draws the circle, it draws the rectangle, it draws our triangle, and then it goes somewhere and writes the text, hello world. Now you can play around with this. Now the problem here is that I think we moved the pen and then we wrote. So I don't think we'd have to figure out how that works. But suffice it to say, now we can actually draw shapes, write some text. The rest is details. Okay? Now, this will not work here because I don't want to experiment with this, but this was actually a flag. So that would be a challenge. Can you draw the flag of Kenya? Can you draw the flag of Kenya using this can you draw the flag of Kenya using these primitives? So if you look at the flag of Kenya, Kenya flag, it's just made of shapes. It's just made of shapes. Let's try and look at a nice simple one. Let's pick this one here. So if I open this in a new, open image in a new tab. So this would be a lovely challenge. Can you draw the shapes of the flag of Kenya? Now, if you can successfully do that, top marks to you. But you have a rectangle there. You have another rectangle there. Now you need to map these out and draw them. Another rectangle there. Okay, and then another one, the white one, and then the green one. Now the challenge would be the shield. But these are curves, as you can see. These are curves, which you can figure out how to do that. How do you draw these curves? How do you draw this one here? So this is probably a circle with a very large radius. This one here. Let me change the color so that you can see some contrast. I'll pick green. So this here is a circle with a large radius. It's just an arc. And this is an oval here. So you have to figure out how to draw an ellipse. This is a rectangle that's rotated at a certain angle. And this is another complex shape. But step by step, you can actually get something quite sophisticated like this. So that's a challenge. I'd love to see if you can actually succeed in this, then you have my attention. Okay, I want to stop here because we have covered a lot of material. I'd like to just do a summary. Let me just make sure that this is going to have animations. So, because I want to go step by step. Let's have animations here, and I want them paragraph by paragraph. Because I want us to summarize this. Okay, let me clear my screen. Okay. So, what have we said so far today? Today we've introduced a rather non-trivial idea of polymorphism. It's a very powerful idea. And I'll ask you to watch the video again and just try and think through them. So the first thing we've done is we've looked at the class construct and how the class construct is a way for us to sort of like a container of attributes. Some of those attributes are values and some of them are operations. The operations are through the methods. Okay, so that's idea number one. The methods are just functions that are tied inside the class. If you recall from the class two classes back, we actually did an example where we had a circle and we were trying to calculate parameters of a circle like the area. And then we just moved that, we did a tab shift. We moved it into the block and it still worked perfectly. It still worked perfectly. It's only that we needed to change some words in it. So watch that video and see the key idea there was the methods are just they're just functions, but they are bound to the space within the class in the class definition. Remember, we said classes are templates, and we use the analogy of baking those cookie cutters, that they are templates. You just use a class to make a cookie. You don't eat the cookie cutter. You don't eat the class. You don't use the class. You use the thing that comes out of the class. You instantiate objects from the class. And inheritance, we looked at inheritance. It's much more straightforward. The very powerful OOP feature that allows you to share attributes. And we saw this with the square. The square borrowed from the rectangle. And in the same way, our canvas borrowed from the turtle.turtle screen class. We didn't have to implement everything afresh. We just borrowed a lot of things from it. So this is how you share attributes among related classes. These classes are related. They have a very strong relationship to one another. And then polymorphism. This it's a very abstract thing, but once you get a grip of it, you will find there's a lot of power in it. It allows you to delegate the behavior, and the class itself will be responsible for coming up with what that behavior actually looks like. So those are the key ideas from this. I think I'm done. For further reading, you can, so the advanced things you can do with classes. So there are special methods that you can also define, but I won't cover that now. There are other things like class methods, class attributes. We won't cover those now. These are just the basics. And I would really encourage you to try out that exercise. Try and make the flag. I'm going to put this as a task. Try and make the flag, the Kenyan flag. Not material. This is going to be an exercise, an assignment. Create the Kenyan flag using shapes. And I'll put for you the link to that. And I'll assign it to everyone. So this will be for your polymorphism. There are no marks, but it's just for you to try it out. Try that out. Start off with simpler things. Start off with a triangle, for example. How would you define a generic triangle? Like, what do you need to know to define a triangle? So I will stop here. I'll keep my screen open in case you want to reference something on my screen. Any questions? Okay, so I will take silence to mean that no questions. I know that this was difficult. I'm going to push the code for you to then have a look at it. Text to write to the screen, to the canvas. And please have a look at that code, pull it, play around with it, try and see the things you can do with it. Now for Friday, we will completely shift gears and now we look at some numerical libraries in Python. So we started off by looking at the introductory material, which was how to work with atoms and IO and operators in the first 3 days. And then these last 3 days, we've gone into something very advanced, which is object-oriented programming. But it's so powerful. Once you understand it, then you'll begin to, it gives you a lot of power. Now, for the next 3 sessions, or 2 sessions, I don't know how many they are, we'll need to decide. We shall look at some libraries. We shall look at a library called NumPy, which is the mother of all numerical analysis in Python. NumPy is a very powerful library. Like it defines multi-dimensional arrays, and they don't have to only be, I think you can make, I don't know if you can make, no, I think they're just always going to be arrays. And when you think about it, arrays are really useful when it comes to representing certain things like images or actual multi-dimensional data. So arrays are really powerful. And NumPy arrays are the bedrock upon which everything else in numerical computing is done. If you want to work with deep learning, you'll work with the equivalent of NumPy arrays, which are called tensors. The tensors are just now multiple dimensions. They can be 2, 3, 4, 5 dimensions. But NumPy is a starting point, and it is such a rich library. It's unbelievably rich. There are hundreds and hundreds of things you can do with arrays. So if you're working with images, if you're working with, there are mathematical functions you can do on these. So this is a fundamental library that you need to master. The next one we'd look at is SciPy. SciPy now takes NumPy and does practical things with it. So within SciPy, let me just show you, within the documentation, it's got a lot of algorithms. So let's just look at the API reference. So the API reference is where you usually go to, and there are all manner of things you can do with it. Let's just see. Oh, the user guide. Aha. So here you can see there are cluster algorithms. There are constants. You can do differential equations, fast Fourier transforms. There are all these things. You can do integration, interpolation. There's file I/O, high-speed file I/O. There's linear algebra, multidimensional image processing. I don't know if you can see this. Sorry about that. Let me make this one full screen. So there are all these things you can do. Linear algebra, multidimensional image processing, optimization, signal processing. And these are relevant for you as engineers, especially if you're an electrical engineer. And there are special functions like Bessel functions. There's a lot of statistical stuff you can do. Let's just look at that. Probability distributions. It's so packed full of so many things. And then another library which is so important is for visualization called matplotlib. Plotlib. So this library is now used for visualization. So they usually go together. NumPy, SciPy, and matplotlib, they go together. And it provides, for example, it has a gallery. Let's just see. I don't know where the gallery is. Let me just zoom in. So it has all sorts of graphs. They have a, where is that? There is a gallery somewhere, plot types. So they show all types of graphs that you can do. And they're quite straightforward. And let's just look at one of them. So for example, if you wanted to do a very simple box plot, let's look at a box plot. And I'll just try and highlight a number of things that you'll really be familiar with. So this is the simplest plotting function. It's called plot. We do an import and we use NumPy, and there are some attributes to set. You can choose that, but you're just doing assigning. We're using some of the functions from within NumPy. Look at these operations. There's sinusoid calculation there, sinusoid, and then you do plotting. And you can actually run this directly and play around with them. But it all begins from these basic ideas of using NumPy, SciPy, and then matplotlib. And then from there, the sky is the limit. You can use pandas, which is for data science. You can then now go into other libraries for image processing, like PIL library or OpenCV. And it's just good to have a good grasp of this because you may use some of these in your final year project. So I will stop talking now. I see the class has reduced to half of what it usually is. And I will say adieu until Friday morning at 8 when we shall have our first session on NumPy. In the meantime, please try out that exercise that I gave you. Try and draw something simple. It doesn't have to be the flag. Just try out something simple and then put into practice what we have learned. Out of context, what is Jupyter used for? So I don't know what the PR is there for. PR. Just Jupyter. Jupyter, okay. So Jupyter, let's just go to that. So Jupyter is an interactive tool. Let's just look at that quickly. So it's designed, it's a way to do interactive analysis without having to without writing individual scripts. So for example, let's just see, I don't know if, you can try it out. Good. So let's see, kernels. So let's just try this one out. Jupyter Lab. So instead of using PyCharm, for people who are doing data science, you'll do a lot of exploratory work. So this is an example notebook. Now it looks very complicated, but it's got cells, these cells here. But then when you plot a graph, so example, if we run this step by step. Let's just see. Usually you'll run each cell and you can run this from here and it'll actually plot for you the graph. So matplotlib is building, okay, so there we go. So it's actually just run this right now. And you can also do this from within PyCharm. So PyCharm has an option where you can create Jupyter notebooks, but it's for interactive. Each of the cells, you can also format them. They can use something called Markdown, or you can use LaTeX for formatting and just making things look nice. But it's a way to create sort of like a notebook that shows the analysis that you've done as you are exploring a particular topic. So this is mainly for exploratory data analysis. It's not used for production code. If you want to get code in production, you then have to now write it into scripts. Any other questions? Thank you for that question. Great question. Okay, then. So that's it for today. Have a lovely rest of your day. We meet on Friday when we shall look at NumPy and we shall try and do the exercises that I've given you. Take care. Bye.